How's it going, everyone? Welcome back to another podcast. This is Unwinding the Spool Podcast. My name is Andrew, and I'm joined by one of my good friends, Will, and we are two guys who are heavily involved in 3D printing and making and just building cool stuff. On this podcast, we talk all things 3D printing, and we've done a few episodes now talking about some of the basics, getting your first printer, and some of the CAD, computer-aided design softwares you use to design your models. And in this episode, we are going to be talking about slicing software, what it is, what it's useful for, and some of the details around setting it up for your print. Will, do you have anything to add to our intro?
I think it's going to be a good one. This is pretty specific, but I think this is a step that not a lot of people think about when they first get in the game. And I think that this is something that everyone should kind of understand and know about the process. So listen close. If you listen to, we noticed a lot of people really enjoyed the buying your first 3D printer podcast. This is definitely a really important one to listen to if you just bought one or you're thinking of buying one.
Exactly. So to kick it off, let's talk about what is slicing software. Do you want to answer that question?
Sure. So Andrew and I, in the What is 3D Printing podcast episode, we talked a lot about kind of the hot glue gun analogy. You're going to take your hot glue gun, you're going to squeeze some material, it's going to go layer by layer. But the only way that the machine knows how to go layer by layer is through the act of slicing. So when we have a model, when you make it like out of clay, let's say you make like a bust of a person out of clay, you're kind of making it organically and taking a material and you're kind of shoving it into the positions that you need it to be. However, in 3D printing, what we would do is take like the model you've made and then you slice it layer by layer very thinly. And each of those layers then represents a amount of material and a direction for the extruder head to go. And then it just repeats that over and over and over again until it's sliced the model from the bottom to the top. It's sliced everything.
Right.
And so these softwares basically allow a three-dimensional object to be translated into many two-dimensional layers.
Right. Yeah, exactly. How I kind of describe it is like all these stacks of these 2D cuts of your model are like the GPS roadmap for the printer, like turn left, go right, go up, go down, and so if another good visual, because I'm a very visual learner, is like, think of like a tiered wedding cake, right? So it's kind of a more, basic analogy, but, as you build up your wedding cake, maybe like the baker with the frosting kind of, he makes all the cylindrical tiers and stacks them on top of each other, but then smooths frosting over it. So you can't really see that, So if you like peel back the frosting, you'd see all those tiers of the different layers of the wedding cake that they stack on top of each other. That's like what the slicing software is doing, is taking your model, like Will said, and just cutting it into usually hundreds of layers, depending on your settings.
Sometimes thousands if you're in
depending on how big the model is, right? And it just gives the printer the roadmap on where to go for that 2D space, because 3D printing, in essence, is 2D printing over and over again.
Exactly. It's
right.
taking a idea that is two-dimensional and just layering it on top of itself.
Right.
So that is exactly why you need. And I mean, Andrew, do you want to go into kind of why we need a slicing software?
Sure. Yeah. So basically, the general workflow for 3D printing, for those that don't know or for those that are learning, is, like we talked about in our last episode, building your CAD model, whether you're, designing something from the ground up and all the different CAD softwares you can use, or if you're just downloading a file, you kind of skip one of these steps. But let's say you're building your model completely from the ground up. Well, you're going to start in your CAD software and you're going to save that file. Well, all CAD softwares, for the most part, share similar file types, but there are some that have native file types, like SolidWorks, one of the softwares that I mostly use. Its native file type is a .solid part file. And then there's non-native CAD file types like step files, IGES files. And what you're going to need to do with your CAD file is save it as an STL file, or I even think people use like OBJ. Is that another one?
Yeah, you can use an OBJ, an object file, or a stereolithography file.
Right, and then I think a 3MF is also something that people use.
That's like a project file, but yeah, you can also use a 3MF.
Yeah. Sure. Yeah, I'm mostly just done with STL files or worked with STL files. So you're going to use your CAD software to save your file as an STL file. So basically what that's doing is the CAD software is interpreting the model and basically taking the surfaces and triangulating and building like a mesh. And I'm not the. I don't know. Do you have a better way to describe kind of like how
you're totally right. Like it's definitely like what's happening when you save a stereolithography file is for an object in most native computer-aided design softwares has a lot of complex math, giving it the geometry that it has. But in order to get it printed, you have to make the math way dumber. And so it has to be points in space. It can't be anything super complex. So what it's doing is taking your model that currently has smooth surfaces and like hyperbolic lines and lots of uses of irrational numbers and things like that.
Right.
And what it's then doing is taking and making it into a mesh, and it's just all triangles. That's all it is it's a bunch of different triangles. And that's easy because now it's just points in space that have relativity to each other, and that creates this model that can then be interpreted by something like a slicing software.
Right. And depending on your settings in your CAD software, your STL triangulated file can be very fine. You can have really fine triangles. That's obviously going to make your file size larger, but it's going to make your model probably smoother. Or you can have a very coarse STL file where you'll see a lot more of the approximations for curves. So like a curve, instead of being really smooth, you might see like kind of studded lines that as it's approximating the curvature. So that's kind of like what you're doing. You're going from a CAD software file to an STL file, and then you're bringing that STL file into the splicing software or OBJ, but most of the time people use STL files. And then the splicing software, depending on whatever one you use, is going to, like we've already said, slice it into hundreds, thousands of layers to give the 3D printer its roadmap on where to go for each layer. So it's going to do if you imagine, like if you cut a model into one profile, like a two-dimensional profile, it's going to just look like, something you can put on a piece of paper. So you're basically going to have hundreds or thousands of those profiles. And then the printer follows that. And for every profile, after it finishes that one, it moves up by whatever your specified layer height is.
Absolutely, yeah. And I mean, that's basically allowing the slicing software allows this map of points in space to become a roadmap for each layer, as you said. It's that like now we've gone from complex math that it's very tough to interpret outside of a design software. And then we have to take that, now we have it to simple points in space. Well, points in space still can't be 3D printed. So now we have to go, we're going to take each point in space and look at them all in each layer. And then we're going to make a two-dimensional, almost like racetrack map. Mm-hmm. And that is what we're going to, that's the thing that the printer can go, oh, I get that. I know how to do that.
Right. Yeah. And not only that is it giving the printer a roadmap, it's telling it how to go about driving on that roadmap. Are we driving really fast? Are we driving really slow? What type of car are we driving? Like your nozzle size. Are you driving a semi-truck? Exactly. You're being very coarse, or are you driving a Ferrari and being very precise and fine, Little reference to car stuff and some big.
Oh, there we go.
But yeah, there's a lot of settings that you can tune in a slicer software, all the way from temperature to speed to support material, which we'll get into in more detail later in the episode here. That's kind of why it's necessary. It's required to put your 3D model file in the right format so that the printer understands what the heck it needs to do to extrude the material and build your model.
Right. And also the last point I want to say is we'll talk a little bit about infill settings and things like that. And, I think there's some common misconception, like a 3D printed part is solid. But that would take an insane amount of time to print each layer solid. And that's why we talk about this as a roadmap, because what it's going to do is it's going to take this three-dimensional object that's hollow, That's how all three-dimensional objects are. They're entirely hollow. The space has a thickness of 0, like the surface has a thickness of 0,
right?
And it's just a hollow object. And so what the slicing software also does is interprets your hollow object and goes, okay, all this space inside has to have stuff. And that stuff is going to be infill.
Yeah.
And that infill is not solid, because if it is, any object would take days to print.
Sure.
So the beauty of infill and speeds in your infill allows you to make a print go much faster while still getting a solid object.
Yeah. Yeah. And, with optimizing infill settings and like wall thicknesses, you can really optimize the strength of your part. So that's one of my favorite things I like to do is like maybe run a lower infill and then run a thicker wall so the part is still really strong and won't break from holding it or putting force on it. Anyways, I'm getting ahead of myself. We'll talk about that in more detail towards the last point of the episode here. So let's talk about the different kinds of slicing softwares that are available to you as a maker, as a person who operates a 3D printer. Now, I will preface that there are many different kinds of slicing softwares out there. However, most of them use at least some of the main ones as the back-end software that's performing all the legwork. And some of these companies will put their name and logo and design and font and then call it their own slicing software, right, Will?
That's absolutely right.
Yeah.
And I mean, in some case, it's made by like a different printer company. And so that printer company puts their own like settings within it, but it might be based off of a different, like a very like conventional base software. But then one printer company A goes, well, we're just going to pre-import a bunch of profiles and put all this stuff in here so that you already can just, load it up and you're set to go.
Sure. So I think one of the main slicing softwares that we'll focus on talking about is a software called Cura. It's very widely used across the maker and 3D printer community. However, there are other ones that are also freed or paid versions. I've really mostly had experience working with Cura on all my work for hobby and for my day job. But Will, you've kind of used some of the other ones. Do you want to kind of touch on some of the ones you've used before we really dive deep into Cura?
Sure, yeah. So just to touch on some of them, kind of going from most utilized to least. I think the thing I use most, just because I have one, is the Prusa slicer. Mm-hmm. It's the native slicer to the Prusa series of printers. It's a super powerful tool. They have a lot of fantastic mesh analysis tools. Oops. That's me. They have a lot of mesh analysis tools so that you can analyze the model. They also have a lot of tools for helping kind of define exactly where you want the support material to be, how you want all this stuff like that. So there's some really cool tools, but it's specific to Prusa. So you can't use it with any other printer. So that's the thing, is it's optimized for their series of printers. Whereas I've also used one that's for like any printer you can imagine, which is Simplify 3D, which is a software you have to pay to use. But it is a very powerful tool because it also does fantastic work on optimizing your mesh, analyzing the mesh, understanding, once you have your printer settings in it, it understands how that printer works very well. And it's also really good at simulating the print. So a lot of softwares, when you slice it, just kind of shows you what the layers look like. But the Simplify 3D is a great tool where it'll actually show you the tool path movements. So you can see, this is exactly where the nozzle is going to go. And so if there is any weirdness, like it has a random moment where it like is going to suddenly jitter over to the right for some reason because you have a weird model artifact somewhere in it, you can see that. And you can see it, in the playback. And it's obviously sped up, so you're not waiting 4 hours looking at the thing like in the screen.
Yeah, it's kind of like a CAM software built in. So CAM is computer-aided manufacturing, I think, right? Mm-hmm. So you're seeing that tool path. So that's pretty cool. That's actually funny you say that because that was a problem that I was running into with a project at work recently. Is like we were designing some test coupons to actually put in a tensile testing machine to test the strength of various 3D printed materials. And for some reason, even though the parts were being printed at 100% infill, it was still doing, and so they were 100% dense, it was still doing the outer wall structure as a perimeter, and then it would switch from being the toolpath being longitudinal to the part for the outer wall perimeter layers to then doing it transverse. So it was affecting the strength of the part, even being at 100 density. So this is something I was using Cura for that, which is the other software we'll talk about. And there might be a setting deep in there somewhere that I haven't discovered yet to change that, but I'd be curious if Simplify 3D would be good to look at using for that, to have a little bit better control of the toolpath. Because you'll look at some of the, especially like the top layers of a print, like where it's finishing, and you'd be like, it's like goes diagonal and then it switches, and so I'm kind of curious how the people who code this software optimize that. I don't know if it's for speed or minimizing like excess movement, maybe.
Usually when Alder and I were first looking into it, it's about minimizing the amount of cross paths. So how much travel time? It's like, okay, how can I minimize travel time?
Sure.
I want to always, the most effective thing is for it to always be needing to extrude.
Right.
So if it's having to travel and not extrude, that's a problem.
Okay.
So minimizing the travel time and travel distance is important, because then you also have to, when the tool head travels without extruding, it has to retract so it doesn't dribble material on it as well.
Yeah.
Anyways, so that's part of that. And then the last one I wanted to touch on is the Dremel software for the Dremel line of printers, which is a great level. It's great for like education, kind of at home, but out of the box usable kind of use. And the key difference here is like, if Simplify 3D is at the very far end of like hyper customizable, hyper tunable, like you can do a lot of work with that. The Dremel software is at the other end, where it's very like user friendly, but you can't do a whole lot of advanced tuning. Right. You can do some, but it's like very much like pop it in. You're going to put your model in. You're going to choose the material you use, which is they're only used for PLA. Mm-hmm. So you're going to have one material. You're going to go, do I want it to be high detail, medium detail, low detail? And that's all you get to tell it.
Right. Yeah, they're basically targeting the very entry level user of a 3D printer, so that they don't get into analysis paralysis with all of the different settings that you
Absolutely.
Can see. And that's a big problem that some people run into that we can talk about later when we talk about tuning your printing profile in the slicer, is overcomplicating your print profile, especially if you're trying to troubleshoot. A lot of times people are having a certain problem with printing a part, and they change too many settings at one time. That can be as devastating to not changing enough. So like Will was saying, there's Simplify 3D. Do you know how much Simplify 3D runs off the top of your head?
No, let me look again.
Okay. Yeah, so Simplify 3D, I've never really actually had hands-on experience with it, but I've heard good things. If you're in the position to pay for something like that, it might be beneficial maybe once you get more experience. And then there's the Prusa one that, Prusa's a great company. They make great printers, so they have their own profile and slicing software that's tailored specifically for their printers, so they can build profiles that they know work really well on their printers. That can equally be as beneficial. And then the Dremel software, like we said, is very simplified, straight to the point for entry-level makers and 3D printer users. And then there's a bunch of other ones out there. I'm sure we could go on into a large laundry list of different slicing softwares, but a lot of them, like we said, will use the same software running the back end work. I guess I'm not a coder, but like running all of the legwork and the brains, and then the front end, all the stuff you see as a user, and the user interface will be different, so that it looks nicer and it's paired with their machines. And that one that's mostly used for that is Cura, right?
Yeah, absolutely. And then also, just to say that the Simplify 3D is $150 for a lifetime license.
Oh, okay. That's not too bad.
It's definitely pricier. Like, it's definitely you should find a need for it.
Yeah.
Which we did. I mean, when we were working on all kinds of printers at UC Irvine, we had a need for it because we needed all of our printers to be tunable and to be hyper tunable.
Right.
And so you could easily import a printer and then tune it very easily, no matter what manufacturer you got it from.
Sure. Yeah, so that would be a good software, like I was saying, once you get a lot of good hands-on experience, if you're really feeling the need for a lot more customization for your print profiles, then it would be worth the investment. But yeah, let's go ahead and talk about Cura, and then we'll kind of use Cura as our demo piece for talking about kind of like tuning your software or your slicer settings. So Cura is a software. It's free, open source, I think. Open source is the right term for it, but it's backed by Ultimaker. So Ultimaker is a manufacturer of printers. So they're, a lot of the settings in there can be tuned specifically for the Ultimaker series of printers. So that's kind of cool. They have their own specific profiles in there. But then the other nice thing is like I was saying, it's open source. So if you have a printer that, doesn't have a specific profile already listed in there from the, there's tons of different, manufacturers of printers, all the way from Creality to Key 3D to Knophead is one of them in there. Then there's like CME, CNC. So there's tons of, printers that have their own profiles already loaded in. But if you have a very unique 3D printer, or let's say you've built your own 3D printer, you can add in your own, printer's profile. Do you want to kind of describe, Will, what we mean by printer profile, just so people know?
Yeah, so some of the basics of a printer profile are you're going to give it the build volume dimensions. It's going to know how many, like how wide, how deep, and how tall it can build. It's going to need to know where the home station is. Is it like X000 at the corner, at the center? Is it how many extruders does it have? Does it have a heated bed? So there's some basics there. Other things it might want to know is like potentially like how like belt speeds, what belt speeds you can max out at. There are certain like mins and maxes that you might need. It might need a certain amount of power before even like a stepper motor turns on. So maybe you have a minimum speed. It might so there's all kinds of things that you can get in there, but the key ones are like dimensions, how many tool heads, do you have a heated bed, so on.
Right. Yeah. So you'll stick as an entry level user, you'll stick with the basics. But if you're at the point in your AM hobbyist or career where you're building your own printers, you can have the option to completely build a profile for your specific custom printer from the ground up. So absolutely. Let's say you bought a Creality printer off Amazon, you get it, and what's kind of like the first step? You want to load in the pre kind of specs profile. Let's talk about some of the basic settings that you should target first, and then we'll kind of get into some of the more nitty gritty settings.
Yeah, absolutely. I think the basics you're going to want to look for with you bought a Creality out of the box. You're looking at your nozzle temperature. So that's how hot the nozzle is that's extruding the material. You're going to want to look at your heat bed. If you have a heated bed on it, you're going to look at that temperature, the heated bed temperature. Those are two very important things. Those solve a lot of problems. Like when we closed loop plastics, we have a lot of users that run into adhesion problems. Most of that is they're using the lower end of our settings, and we say, okay, go to the higher end. Don't go at the 230, go to 245 for the nozzle temperature. Don't do the 100 degrees Celsius, do 110, do 115 for the bed temperature. So there's those two knock out a lot of your problems right away. Yeah. Those are a lot of the big problems. And you have to look at your material. What material are you using? And that's going to get you very specifically what you need to do. The other one would be layer height as well. Those are kind of the three that I would knock out. Layer height is going to give you kind of like the detail. So a lower layer height means more layers, means better detail. However, it means a lot more time.
Yeah.
Whereas if you use a larger layer height, you're not going to get as much detail. But if you have a larger model, it's going to blow through it a lot faster.
Sure. Yeah. So like the most, and I think you could probably change. I don't know if you can change the units in Cura. Have you ever experienced with, or have you tried doing that ever?
What do you mean, like millimeters to inches or whatever?
Yeah. Because I know stock. No.
No, so everything, all the slicers will convert them, but everything is in millimeters.
Okay, so most of the world uses the metric system anyways, but if you're a person who's heavily reliant on inches, feet, yards, even though you're not going to be using yards in your slicer software, you're going to have to use millimeters. Although it is kind of, it can be a little frustrating, like if you're building a model in SAE units with inches and whatnot, and then understanding like if you're trying to troubleshoot like part sizing so that like you get correct fitment, it can get a little troublesome going between inches and millimeters or centimeters. But anyway, so Cura and most other slicer softwares are going to run in the metric system. So your layer height, as Will was saying, is going to be usually between like 0.1 and 0.2, I'd say is the most common range. For Prusa's and some more higher end machines, I think you can even get down to 0.05, right, Will?
Yeah, you can do 5 microns of 0.05, and you can also do, some of my printers I've run like 0.3 layer height, so much for the draft.
Okay.
Yeah, pretty tall, like draft stuff where you're just like, I got to get this out and just want to see it.
Yeah. Oh, and the other thing I forgot that's an important part in your printer profile, which is going to determine a lot of these settings, is your nozzle diameter.
Right.
That's another big one. So most printers will run a 0.4 millimeter nozzle. However, for general prints, some people will run finer nozzles if you're working for to achieve really good detail, and then other people that have large format printers will up to like even a 0.8, I think, or even do they have 1 millimeter nozzles? Do you know?
I know some people, if you run like the Volcano hot end with like a 1 millimeter, you can get really quick, gigantic volume printing. Yeah,
right. So you're going to definitely lose like precision, or not precision, but you're going to lose quality and resolution.
You're going to lose detail. It's got to be.
But it'll go way faster, and it's kind of funny. I've watched some videos of people that use really wide nozzle diameters, and how fast the printer goes through material is kind of common.
I'm sure. Yeah, exactly.
It's like a Hummer basically consuming.
Exactly.
But yeah, so that's another thing. So your nozzle diameter, when you're setting up your printer profile, you're going to want to make sure that that's correct. But if you're doing a printer out of the box, most of the time they come with a 0.4 millimeter nozzle. So layer height is a big one. And then let's talk about infill. So infill is another big one that's going to greatly drive how much material you're using and how long your print is going to take to finish. So infill, like Will was kind of saying earlier, is the amount of material on the internal structure of your part. So anywhere where you can't see inside the walls of your part, there's going to be some type of infill, because like Will was saying, if you print at 100% density, it's going to take forever and use a ton of material. So to circumvent that, the slicer software creates this infill pattern, and how fine the infill pattern is dependent on your percent. So there's different patterns that you can use. So there's like grid patterns for infill, so you can just do basic like square cross hatches. Yeah, so you can do lines, like diagonal or straight lines, triangles. I think the one I use most of the time is trihexagon, so you kind of get like a cool honeycomb. Like if you think of like a honeycomb look, that's what trihexagon. Cubic, octet, concentric, zigzag. There's a bunch of gyroid. So
gyroid infill's really cool. I use that on a lot of my models. Yeah.
Okay. So there's a lot of different patterns that people will use. Sometimes, like if you're doing a lot of printing if you're trying to really optimize how well a certain part prints, some people find a certain infill pattern works better than others for giving the part strength or optimizing speed or material usage. But like I was saying, most of the time I use trihexagon. Will, do you kind of lean towards any specific pattern?
I usually use grid or gyroid. Those are kind of the two that I use.
Okay.
I think that gyroid on the Prusas works really well because they've been optimized for that, and it's very fast because it's pretty smooth. It's not a lot of like dant. It's very organic and kind of flows around itself.
Okay. So maybe it minimizes like retraction by having
it kind of minimizes the amount of like back and forth there is for sure.
Yeah. Okay. Cool. So so then obviously you have your density is kind of the second option, and there's one thing that you'll learn if you kind of download the Cura software or the other ones. There's tons of deeper settings that you can get into for each major kind of subject area of your slicer software. So if we opened up, like if I open up here the settings or all the preferences, like you can easily get into probably over hundreds of different settings. So I just warn you and give caution to not trying to change too many settings at once, because it can cause more headaches than help you. But the main one, infill density, obviously if you put it at 100%, it's going to make that thing like a solid block of plastic, basically. Otherwise, if you do like 10%, it's going to really make the spacing of your grid or your hexagon a lot larger. If you do closer to like 50%, it's going to make those hexagons smaller and kind of more tightly packed together.
Yeah, I mean, general rules, I usually do about like 15 to 20.
Yeah, I think.
And then on models where it's like optimized or I like really want it to print fast, I go to like 10.
Yeah. So if that's the other thing too, is like obviously 3D printing is really well known for being a rapid prototyping solution. So if you're trying to just design a part, see how well it feels in your hand or how well it fits with another part, you don't want to spend a ton of time printing something that you might throw away or recycle into new filament. Closed loop plastics.
Hashtag CLP, hashtag closed loop plastics.
But yeah, so you're going to want to minimize the infill there, so it takes less time to print and you're not burning through so much material for all your prototyping stages. And then once you get to a final part where you're like, okay, I know this design works well with whatever my end use application, I can bump it up to 50% if I want it to be a little bit denser or feel a little bit more robust. So that's a big one. So then we kind of already talked about the material temperature and build plate temperature. There's some other settings. Do you want to, because it's in the materials category here, do you want to talk about what retraction is, Will? Because that can sometimes help you when you're switching from different kinds of materials.
Yeah, and also, so retraction is just retraction speeds is how fast the motor that's pushing material through the nozzle goes in reverse. Mm-hmm. Such that you are not dribbling material out as it's moving around. If you're having like a lot of stringing issues, retraction's really useful. If it's like leaving material behind as it's traversing and doing things like that, retraction's a super useful tool. Sorry, I don't know why I'm yawning. Yeah, I would say the retraction speed is it's also useful if you're having a softer material, mm-hmm. and so it has kind of a tendency to like goop out as it's moving around.
Yeah.
So when it's pulling back, it's kind of forcing the material to stay back up inside.
Yeah.
The nozzle.
As you're printing, you're actually kind of building up some pressure in the nozzle as the material is trying to be forced through a very tiny orifice. While it's melting, you're building up some pressure. Right. So inherently, just like kind of how a glue gun works, it wants to keep oozing out. So the retraction is going to tell you how fast does it suck that material back in and how far does that motor turn to suck that material back in.
Right, exactly.
So I've found especially like PETG is a common material that really likes to string a lot. So you kind of got to make sure your retraction settings are well tuned. And then TPU, obviously, because it's a soft, flexible material.
Definitely TPU.
Use a lot and create little boogers around the parts, basically.
Ooh, boogers.
But yeah, so that's another big one there in the material settings. So next one is kind of speed. So you want to talk about kind of, I know it's kind of a pretty basic one, but.
No, but speed. So there's a couple of different speeds. There's sometimes some softwares give you just an overall printing speed. So that's how fast it's going to go in millimeters per second in terms of how fast it's going to move while it's doing the extrusion motions. So another speed, and that's going to be dependent on how accurate and fast you want your model. Mm-hmm. If your X and Y axis are like dialed in and there's no vibration and how fast it moves, then you can probably really pump that thing, pedal to the metal, baby, and it'll still be accurate, even if it's going like beep, 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 beep. But if you're like most of us mere mortals and don't have your, thing perfect and dialed in precisely, having it be a little slower gives you some cushion so that it doesn't like overshoot itself.
Yeah.
And so that's in terms of printing speed. There's a couple other speeds, like you're going to have travel speed. A faster travel speed is great for optimizing your print speed, but if you have delicate pieces and it travels too fast and just kind of knocks itself into something, and mm-hmm. it might break your model in the middle of the print.
Like if you're printing like a Hogwarts castle example and you've got all the little spires, you don't want to break off your I don't know, random example. I don't know how that.
No. I mean, that's a common one that you see for like people testing out like their stringing.
Yeah.
And you'll see if you do your travel time too fast, it'll just knock stuff off. Even if it's supposed to be perfectly level,
right?
Nothing's ever perfect, and sometimes you have things. Don't forget, all this plastic is like cooling at different temperatures, and things are warping slightly out of place, and maybe we can't see it with the naked eye, but it might just slam right into something.
Sure. Yeah, no, I'd say speed is a really good one. Start at the stock profile. So not only in Cura and your slicer software do you have profiles for the printer, but you also have profiles for the material. So when you download Cura, it's going to have preloaded profiles for most of the common materials: PLA, PETG, ABS, TPU, ASA is another one. So the people who built the slicing software have optimized, based on experience and use, like, okay, these are the settings that most people use and have relatively good success with. So that's always a good baseline to start at. Especially if you're having trouble with your printer, having issues extruding or being accurate, you definitely want to slow the printer down, because you're going to give yourself a lot better chance for success if you're printing slower. It's worth it to have a print take 15 hours versus 10 hours and have it be successful than rather have it get halfway through and have to start all over again.
Exactly. You got to play that pros and cons game.
Right.
And you also, another thing is your manufacturer of the material will almost certainly have a profile, some settings that they have listed out either on their website, or you can, if they're more local, you can give them a call. I know for our materials, we have all of the settings you need, including speeds, full profiles on our website.
Yeah.
Closewithplastics.com. Quick plug. And so it's definitely one of those things where if you want to add to a base profile, so if you say you have a special PLA, like I get a lot of Matter Hackers build PLA. You look at those settings, because then you can go, oh, okay, like this is what the slicing software says from a basic standpoint, but maybe I want to adjust the temperatures. Maybe I want to adjust some of the speeds.
Sure.
Only adjust what you think, like what's already like labeled for you before trying to troubleshoot beyond that.
Yeah, right. Yeah. Start with the filament manufacturer settings, like Will was saying, try it out, and then this comes with experience, but based on how the part prints, then you can go in and change the settings. Like, good example, like about this time last year, I really started using the tough PLA or PLA Plus a lot more. Right. And a lot of the filament manufacturers for that will say, oh, you just print at the same temperature as standard PLA. Well, I was having, and I was using, I believe it was Hatchbox was the material for that. Or Overture. I think it was Overture, actually. And so their recommended settings were about the same as their PLA, and I was getting tons of under-extrusion problems. Like, my parts were very spongy because it wasn't extruding the amount of material required. So I print my PLA at like 205 nozzle and like 60 bed temp. I actually bumped for tough PLA Plus. I bumped it up by 10 degrees C on the nozzle. So I print that at 215 and 65 degrees on the bed, and it solved all my problems. So
right, and I mean that's a classic example of not trying to, solve too many problems at once with too many different settings.
Yeah, definitely.
Just focusing on temperature first, because temperature is the number one game changer for a print. That is going to affect it the most.
Right. And I'd say, under like being a good 3D printer or a user of 3D printers really requires you to be a good troubleshooter. So you print a part, it comes out maybe not as how you wanted it to. Seeing the part, and whether you do research to learn or you just know, it was stringing a lot, so I got to up my retraction. So it's like a lot of cause and effect type analysis, and knowing what settings to go in and adjust. Try your print again, and then see what happens. But like we were warning you earlier, don't change too many things at one time. It's a classic example of, like, even if you're a chemist in a lab, you don't want to change all your variables all at once, because then you don't know what worked or what made it worse, right?
Exactly. And it's one of those things where you can get analysis paralysis, as you were saying earlier, about just kind of that idea of oh my God. I remember looking at like all the advanced settings in Prusa Slicer one time, and I was like, how the heck? And actually, it's interesting. Aldrin, my colleague, and Andrew and Aldrin and I were all on the same research team for a while. He's really good at just like only going piece by piece. Starts off with we call it, the low hanging fruit, or the high yield guys, like temperature, layer heights, Z offset, these kinds of things. And then starts going down the list. But once, he made some really good profiles for when we first started working on our hips products, because it was like, okay, he wanted to get down to like all the different speeds, calibrate all of it. And we'll go over this in the troubleshooting video, which is there's also great test prints you can kind of do to tune each and every piece.
Right.
So that way you can kind of go down a list of items, or go through a list of prints and look at how they come out, and then kind of tune from there.
Yeah. Right. Yeah. No, that's really important to be a good troubleshooter, and just look out for the small details. And not only like, are a lot of your settings going to be driven by the type of material, like whether it's PETG, PLA, the manufacturer of the material, but also your printer. So, a printer that runs the same setting, or a print that runs the same settings on my printer, a Creality CR10, might yield completely different results, or maybe not completely different, but significantly different results than what Will might get on his Prusa. And that might not always be the fault or cause of the printer itself, and like the hardware it uses, whether it's the type of fans that it uses for cooling, the nozzle or the part, or it could just be environmental settings. Like Will might have his printer next to a window, so he needs to print at a hotter bed temperature to keep it from popping off the bed.
I was literally about to talk about that. Yeah.
Yeah. So environmental settings are a huge part of like, where is your printer located? Are there air conditioning ducts? Is there a window nearby? Is it in an enclosure? Because that might completely change your print settings. There's a lot of things to consider. So let's finish off going down the list, because we're kind of almost at the bottom here with the Cura kind of basic profile. So cooling. Do you ever mess a lot with like kind of cooling settings?
Yeah, so I think cooling is another. Let's say you get through your temperature settings, you get through your layer heights, you get through all that list, as Andrew says on that Cura profile, and you're still having issues with kind of the key issues with cooling are if things are starting to droop, if things aren't adhering very well. So if it's not adhering to the bed very well, or it's not adhering to itself very well, usually that means your fans are too high. You're having too much cooling. It's cooling to, like, all the plastic's cooling so fast it can't even stick to itself. So that's an issue. If you're seeing like drooping, or elephant's foot as we call it, where it's kind of like bowing at the bottom, squishing at the bottom, all these things, that might mean you have too little cooling. And on some materials, we've printed in some materials where we had, or if you print in this is also environmental, if you print in like a very open printer in a very well ventilated cooling space, you might not need any cooling. I've had plenty of profiles where I'm like, don't turn the fans on at all. You're just going to mess things up.
Right.
That's definitely something that I've definitely had in the past. But then there's also some that really do need it, and they need a lot of it.
Sure.
And cooling is generally based on speed. What percent of it's usually a percentage, where what percent of the maximum speed do you want the fan running at? Right.
Yep, exactly. So normally most printer or material profile settings in your slicer are going to be set at 100% fan speed. For PETG, I usually knock that down to like 40%.
Yeah.
Just because you want it to really stick to itself well. Otherwise, I've had it where the PETG wants to stick to the nozzle more than sticking to the part that it's printing on.
Absolutely.
You want that material to stay hot, especially with ABS. ABS has tons of problems with part cooling and cracking and warping. I wish I could print ABS better. I've never had good luck with it.
We gotta work on it, man. I love ABS. ABS is great.
Yeah, I'm going to try getting into more, either ABS or ASA, because that's a pretty common one used for like car parts. People like ASA.
Well, and I'm sure we'll do an episode on this, maybe even like an in-person one where we'll go sit in front of your new enclosure you just built, because I think we can get some pretty cool content talking about why. Because we've talked a little bit about it here, where this like also environmental. Keep in mind, your printer exists in the environment you print in. So if you're I'm in this office that's all closed up and very insulated. Like that's a different occasion than like where I used to have the printer by a big old open window, or when Andrew and I ran a print farm at UCI, where we were in this very hot office or school room that had like really high ceilings, so it had a weird draft, and it was all this crazy stuff.
Yeah, at work with the two Coralities we have in the office at work, they sit right below an air conditioning vent, and so even we found it on the printer that's closer to the air conditioning vent, we have problems with warping, even with like a basic material like PLA. So we're trying to see about building an enclosure of some kind of. You want a consistent environment and in a controllable environment.
Absolutely.
So that's really important. So print cooling is another one you can mess with. Don't spend tons of time on it. Just stick mostly with just the percent of the fan speed, or just turning print cooling off altogether. Don't dive too into the detailed nitty-gritty settings with cooling. So there's two last sections that I think we should touch on. And then the other thing that I forgot would be really important to talk about before we end this episode is kind of like setting up your parts on your build profile, because the orientation of your part on your printer's build profile in the slicing software is really important. So anyways, in the Cura profile, the next section is support material. So you want to talk about this, or...
No, you go ahead. I think you have more. I don't tend to mess with this.
Okay. So support material obviously, is important for certain parts. So we've kind of talked about this in I think it was like episode 1 when we talked about what is 3D printing and some of the drawbacks. So 3D printing can have a tough time with bridging material or bridging gaps.
Mm-hmm.
So if you imagine you have two vertical pieces of your part, and then you have to kind of create a roof over your 3D printed house, basically, depending on how far apart or how big your house is and the type of material you're using, the printer might have a hard time spanning that gap with nothing below it to support the material while it's still in a molten state while it's cooling. So how you circumvent that is you can either change the orientation of your part, change the design of your part, but sometimes you're limited and you just have to have support material. So if you're not able to change the design or change the orientation of your part to not put in support material, then you have to use this setting. And if you can avoid it, it's favorable, because support material, when you pull it off the part, it'll kind of give you a rough surface that isn't as pretty. So if you can avoid using support, do it, but sometimes it's absolutely critical. So what this does is support material is basically like a sacrificial material that's printed in a much, I'd say, less dense nature. And so it's designed to be broken off the part after your part is done printing. So a lot of times you'll pull the part off your build plate, and then a lot of times people use like needle nose pliers, and they kind of just go in and grab the support material, and it kind of rips off. And depending on how you optimize your support material settings, sometimes it'll rip off a lot nicer than others. And then a lot of the other times you spend sitting there with the scraper and jabbing your fingers trying to get the support material.
cutting your hands open, trying to get the dang stuff off.
Right. So one of the main settings for support material is whether you want to put it in there completely or not, because that's the one thing is the slicer software will know based on the geometry of your model, like where it thinks it will need support material. Based on the maximum overhang angle that you want to specify. So if you don't want any support material, even though the software might think you need it, you can turn off this feature completely. Or you can opt to only have support material where your part is touching the bed. So sometimes I'll have a piece where there's a spot on the very bottom of the part where it's contacting the build plate where it needs support, but I have a hole on the top side of the part where the hole is small enough where it can approximate steps and not need support material. Because trying to get support material out of a long hole is not fun at all. So you want to try and avoid that. So you can either choose to put support material just at the base of the part where it's touching the build plate, or you can choose to put it everywhere, as Cura describes it. And then one of the things I've been messing around with a lot more recently is the support material density. So just like you have your infill density, you can also have your support density. And I found that with certain parts, really knocking the support density percent way down to like 5 or 7% really helps you break it off a lot easier, and helps you, not sit there for 30 minutes trying to scrape it all off or get it out with tweezers and pliers. So,
right.
Anything I missed there, Will?
No, I mean, I think that's all the stuff on support material. Also, there are some new pieces within softwares where you can do this thing called painting on support, where you kind of take places where you need it and just paint a little area where it goes, okay, I'm going to just put support down to the bed.
Yeah.
So you can really, in Prusa, you can there's a ton of different ways to define where you want supports. There's also third-party pieces of software that'll generate different kinds of support, like organic supports that look like kind of tree roots.
Oh, yeah.
Build up onto each other.
Yeah, that's pretty cool.
It is pretty cool. So there's a lot of research and a lot of all kinds of alternatives for support. But yeah, the most common thing you're going to see is this grid thing that you have to tear off. And keep in mind that means there's going to be some weird finishes where you tear it off. Mm-hmm. Did you mention the kind of what's called that air gap between the support and the print?
No. Oh, yeah. I know what you're talking about, but I didn't mention
it. So there's a tunable gap that you can do where you can have the contact depth between the support material and your model be more or less. And so if it's less, there's if you have a bigger gap, that means it's easier to take off. However, it's also more likely for the support to just fail and not be useful.
Yeah. Right.
But on the other hand, you can also, if you're having a part that's really delicate and has a lot of detail, and you're just like, man, this needs to just have be right there. It's got to be a zero. There's got to be no gap. It has to be touching it right there. Then you can also do that as well. And so that's something you can screw with. That's definitely one of the really fine tuning things that I wouldn't do until you're I need to get this. This part has to have support. Although I think this segues really well into talking about how you orient your part in a slicing software so you can reduce a lot of things like support material needs, for sure.
Yeah, that's the other big thing on a slicer software is it's how you set up your parts on your printer. So if you're printing one part, pretty easy. You usually put it in the center or wherever, consistent heating. But if you have a part that's pretty complex in geometry, you want to try and think what orientation is best to put, build profile down to minimize the amount of support material, because then you're going to spend less time breaking it off. You're going to have a nicer surface finish, and it's just going to yield you better results overall. And you're going to use less material and it's going to take less time because you're not using that on that sacrificial support material.
Yeah, no, I mean, that's all true. Yeah.
Yeah. So, and then the last one I'll just kind of go over real quick is build plate adhesion. So this is a setting that can really be...
this is a really important one too, yeah.
Yeah, so this can be really useful if you're having problems with your part sticking to the build plate while it's printing. So if you're having your part pop off while it's printing, that's, this is where this could be useful. Or if you're having issues where you're just not getting the material to stick at all, this could be deeper into more material settings, but build plate adhesion could help too. So build plate adhesion, there's a few different settings. So the first one is a skirt. So a skirt is basically a perimeter of extruded material around your part that doesn't actually contact the base of your part. So
it's mostly to clean the nozzle before you print the part.
Yeah, it's kind of like a priming perimeter.
Yeah, it's like a priming. It's a priming maneuver.
Yeah. And then this is also a great time where once you get experiences doing on the fly bed leveling, if you have a skirt that and you're printing before it starts in your actual part, that's obviously the most important. You can see, in this corner the build plate's a little bit too high, or in this corner it's too low. So you can, and this comes with experience, you can adjust the build plate screws with the springs on the fly to get that first layer squished nice and easy. So that really, kind of helps with adhesion just based on optimizing, your bed leveling and the priming of the nozzle. The next one really actually helps with adhesion because it increases the footprint of your part on the build plate, and it's called a brim. So that basically adds it's a very thin, I think it's only the first layer, right, Will, for a brim?
Yeah, it's only, you can have like a couple. So on some of them you can customize it, but usually it's 1 or 2 layers, no more.
Right. So the easiest way to describe it, imagine you're printing a square. So a brim is going to basically be a connected square that's slightly bigger than the footprint of your part that's connected to your part. That just increases how much surface area your part is contacting the build plate. So it makes it stick better based on the surface area that's contacting the build plate. Anything I'm leaving out for that guy?
No, I mean, it's a surface area game. It's all about just getting more hot material connected to the micro kind of chasms in your build surface that allow it to just stick.
Right. Yeah, and bear in mind that sometimes brims can be a little bit annoying to get off because you have to kind of scrape it off with like an X-Acto knife. So if precision and surface finish quality of your part is important, just keep that in mind. And then the last one for build plate adhesion is a raft. I haven't used this a ton. You want to talk about this one?
I love rafts. So a raft is super useful. A raft is what I would call like the nuclear option of bed adhesion. This is like you don't have any flat surfaces on your model. There's nothing that can like really easily contact it. So a raft creates basically a solid layer of plastic and then a grid layer of like very dense support material, a couple of grid layers, and then it builds another layer of solid on top of it, and then there's a gap that you can kind of tune, and then it starts building your part. So basically what it's doing is instead of having your part have to adhere directly to the build surface, it creates a raft of plastic that's the same material. Again, I call it the nuclear option because you're now creating like a whole brick of material you have to throw out. Like it is very much a wasteful part. It's a very wasteful thing, but I have used it because if you have something that has, I have a classic, there was an example. I had a student model something that was entirely just grouped spheres. It was spheres put on top of each other, had no flat surfaces. And so foolishly, I didn't even check it. I said, yeah, I'll get it printed before your project's done. Don't worry about it. And I see the model. I'm like, oh my gosh, it's a bunch of balloons, sphery things. How is this going to work? And then, of course, the raft saved my butt because what it does is it creates this raft that kind of cradled the bottom of the sphere and allows it to create the sphere over time.
Right.
And so that gives you the power to do things that it's definitely helpful. Also, if you have things where it's also useful, you have a material like TPU that like TPU hates to bond to anything other than itself. Mm-hmm. It despises everything but itself. And so PET as well. I've had very good luck with rafts with PET because it's some materials like our HIPS product, the high impact polystyrene, it wants to stick to anything. Once it's melted, it'll stick to just about anything. Right. PLA, when it's warmed up and melted, wants to stick to just about anything. But some materials just don't want to stick to anything but themselves. So having that very simple rectangle geometry that's easy for it to try and stick to something else, and then have your part can really help with some either tough materials or just tough geometry.
Yeah, definitely. And this is that's a great explanation of a raft, and it has its pros and cons, but that's kind of like a do or die. Like I have tried a million other things. I can't get my print to stick, and so I need a raft. But there are other options that you can do for build plate adhesion that aren't related to the slicing software that we can talk about in another episode, where you're using like mechanical ways to what's the right way to describe it? Just physical ways to help with the adhesion.
Yeah, there's ways that are not part of they're not a software based thing. They're a very hardware-based solution to bed plate.
Right. Yeah, exactly. Thank you. So that kind of wraps up most of the settings in your basic slicer software. Those are all the basic kind of go-to settings that most people are going to touch when printing different parts. As we've said, if you expand the advanced settings list in most slicer softwares, you can probably see close to 1,000 different options.
Yeah, you can spend your lifetime trying to find the perfect setting for each one of these things.
Yeah, you could probably
suggest you don't do it.
Yeah, you could probably do a whole thesis or dissertation on optimizing print settings in slicer software. So just tread lightly when you're going into the advanced settings, but sometimes it can be useful. Like I'm still learning about new settings every day, and I've been printing for years now. I just recently, within the past 6 months, learned about the support density setting. So I've been messing around with that. So if you're just tinkering around with one or two advanced settings, it can really help you if you're trying to fine tune a certain area of your print. And then the last thing that we kind of talked about is setting up your parts on the build plate in your slicer software. So if you're doing a pack print where you have tons of parts being printed together, whether it's a bunch of the same part or a bunch of different parts from your assembly, you can orient those into specific positions on the build plate to optimize travel, things like that, heating, anything else, kind of why you place parts differently on the build plate?
Yeah, so it's going to depend on also what strength you want it to have. So obviously the weakest point of any print is between the layers. Right. So when it's easiest to delaminate a print. So whatever direction you need it to be strong in should not be the vertical layer lines. Right. So you want to orient it such that the strongest section is one of your X or Y planes. That's going to be your strongest one.
And 3D printed parts are very similar to composites. Right. They have directional strength. So your greatest strength is going to be in the direction of your fibers of your printed part, because the strength of the adhesion between layers is the least strong part of the print, or strong part of the part.
And there's all kinds of stuff that we can talk about, the crazy stuff that people do where you can bake them or do things make it so that those are better. However, even after that, it's always going to be most strong, or it's still going to be least strong between the layers of the print, where they're just going to want to delam and come apart. Whereas if it's being pulled this way, there's a lot of good friction. You've got all kinds of stuff that doesn't want to let it pull this way and pull apart.
Right. And essentially, it's kind of a continuous fiber bead from printing in the longitudinal direction to the part. So it's pretty cool. Some of the things that the high-end printer manufacturer Markforged has done with fiberglass or Kevlar reinforcement materials for the perimeter is pretty cool. But we can talk about that in another episode. And I think post-processing will be a whole episode, because there's a lot of cool stuff you can do after your part is finished printing to increase the strength of your part, make it more resilient, make it look nicer, etc.
Absolutely, yeah. And I think we can honestly even do a whole other episode on printing, part orientation for sure.
Yeah.
And kind of what you're looking for. Because I think that's definitely something we can look at. And maybe we even incorporate it into our next episode on where to find models and how to use them off of the internet.
Yeah, definitely. So I think in sum for this episode, the thing is you want to get in tune with your slicing software, learn about all the settings, but don't change too much at one time. Start with the basics. Start with your basic printer profile settings, and start with the basic material profile settings from either your slicer software or from the manufacturer of the filament that you're specifically using.
As is said in much of our engineering education, keep it simple, stupid. So that is exactly what you have to do. There's also lots of people who have already figured this out. I would highly suggest not trying to reinvent the wheel. Yeah. Look at the manufacturers of your materials. Look at your printer manufacturer. Really go down the rabbit hole of examining the data they've put out about their material and about their stuff, and I think that's the best place to start.
Sure. Yeah, and on YouTube, people have posted YouTube videos on fine-tuning a print profile for either a specific printer or a material. When I really got into TPU last year, I watched a ton of YouTube videos on people troubleshooting and that took out half the guessing work for me. So
there you go.
There's a lot of research already done that you can take advantage of on the YouTube or on the internet.
The internet is your friend.
Yeah. So
at least in this case.
Right. But there's also a lot of misinformation out there, so don't believe everything you read.
Quick PSA.
So anyway, so that's going to pretty much wrap up this episode. We are into over an hour, so we're definitely explaining our depths of our knowledge when it comes to 3D printing with these episodes. So in the next episode, we'll be talking about something also very interesting. Is that where we're going to be talking about pulling models off of Thingiverse?
Yes, this is where, for those of you, and this includes me and a lot of other printing people, you just are looking for something. You're looking for a tool or a tchotchke or a thing because you forgot it's your mom's birthday and you don't know what to do. So, yeah, you definitely, we're going to go over kind of all the different worlds, the different places you can find models, the things to look for when you're looking at these models, and how to not fall prey to the false promises of models that are found on Thingiverse. So
Exactly.
We'll definitely talk about all that.
Yeah, cool. All right, that sounds good. Thank you all so much for either watching or listening in to this podcast episode. We're so excited to be doing this with you all. As always, if you guys have any comments, questions, or feedback for us, either leave a comment on the YouTube video or shoot us an email at unwindingthespool@gmail.com. Other than that, Will, it was great talking to you this evening, and I'm looking forward to the next episode.
Looking forward to the next one, bud.
All right. See you guys.